Hi, I am Raghavan, Chemistry Faculty from All Fours Colleges. I welcome you all for the All Fours Chemistry e-learning program, session 32. In this 30-second session, so today we are going to discuss about the concept of electron configuration. Okay, in the last session we completed the shapes of various orbitals. That is shape of s orbital, p orbital, d orbitals and f orbitals we have done. Okay, and now today energies of atomic orbitals, and next is the concept of electron configuration, right? So energies of atomic orbitals. Energies of atomic orbitals. Energies of atomic orbitals. See, what are the different orbitals we have? So that is s subshell contains only one orbital, and p subshell contains 3 p orbitals, d subshell contains 5 d orbitals, and f subshell contains 7 f orbitals. Okay. Now energies of various s, p, d, f orbitals. Energies of orbitals. Okay, when, so for example, 2p orbital, 2p subshell, it is 2p subshell, it contains 3p orbitals. Okay, 2p subshell contains 3p orbitals. If energy of all the p orbitals are same, okay, that is identical energy orbitals are called, degenerated orbitals. That means when it is absence of magnetic field or electric field, all the 3 p orbitals possess identical equal energy. So that p orbitals or the equal energy orbitals are called degenerated orbitals. Okay. Now energies of atomic orbitals. What are degenerated orbitals? The degenerated orbitals, that is orbitals having equal energy, are called degenerated orbitals. Okay, that point should remember. Now energies of atomic orbitals, let us write degenerated orbitals having equal energy are called degenerated orbitals. Right? So what is the condition? When the orbitals are take out from, that is absence of magnetic field or electric field, all the energies of orbitals are equal, that is called degenerated orbitals. So now the different energies, how we can identify, that is one, that is degenerated is done. Okay, that is the definition is clear. The next one is, so what is the energies of various, see for example 2p, 3p, 4p, 5p, and different various subshells are also present. So now orbitals with lesser orbitals with orbital, let us say it is orbital with lesser n plus l value, orbital with lesser n plus l value is least energy orbital, Which orbital is least energy? The orbital with lesser n plus l value is least energy. The orbital with higher n plus l value is higher energy. Okay, the orbital with lesser n plus l value is least energy. Okay, and remember, the orbital with higher n plus l value is higher energy, lesser n plus l value is lesser energy orbital. Okay, next, suppose if two atomic orbitals, see for example n plus l values for 1s orbital, 2s orbital, 3s orbital, okay, and 2p orbital, like this we have various different orbitals are present. What is n plus l value for 1s? So n is equals to 1, and for l value for s subshell is 0, that is equals to n plus l value is 1. For 2s orbital, n is equals to 2, and l value for s orbital is always 0, so that is equals to 2. Next, for 3s orbital, it is n value is 3 and L value for s orbital is always 0, that is equals to 3. And for 2p orbital, so n value is given 2 and L value for any p subshell is 1, so therefore it is equals to 3. Yes, the orbital with lesser n plus L value is least energy. Okay, 1s orbital among these 4 orbitals, 1s orbital is lesser energy because n plus L value is 1, least out of 4, least for this one. Okay, next, sir, here it is for these 2 orbitals, that is for 2p orbital and 3s orbital, the n plus L value is same. Okay, then how you can decide the orbital with lesser energy? Okay, next concept is, if two orbitals have same n plus L values, if two orbitals have same n plus L values, okay, so then the orbital, okay, if the condition is like this, then the orbital with lesser n, okay, you have to compare these two are having the same n plus L values, the orbital with lesser n, so out of these two, lesser n is 2p orbital, the orbital with lesser n is least energy. Okay, least energy, you got my point? Okay, if two orbitals have same n plus L values, then the orbital with lesser n, the orbital with smaller n, okay, is the least energy orbital. So out of these two, now decide which is least energy, 3s or 2p. So 3s orbital n plus L value is 3 and 2p orbital n plus L value is also 3, but the 2p orbital n value is 2. Okay, so it is smaller than 3. So therefore, the 2p orbital is lesser energy than 3s orbital. Okay, like this we can decide energy of the atomic orbitals. Okay, that is the energies of atomic orbitals is essential to write the electron configuration of elements. Okay, first, once again, what are degenerated orbitals? The degenerated orbitals are the orbitals having equal energy, identical energy orbitals are called degenerated orbitals. You should remember the points clearly. Then orbitals with lesser n plus L value, the orbital with lesser n plus L value is least energy orbital, Suppose if two atomic orbitals have same n plus L values, then the orbital with lesser principal quantum number, okay, the orbital with lesser principal quantum number, that is n, lesser principal quantum number is the least energy orbital. Okay, so this is about energies of atomic orbitals. Okay, so let us practice some more examples of the same. Okay, so we have done some examples, let us add some more examples. So 3s, let us take again 3s, 3p, 3d, 4s and 4p. So here we have taken 4 and let us take some more 4 orbitals. Okay, now in this n plus L value, 3 plus 1, that is equals to 4. 3 plus 2, that is equals to 5. Here in this 4 plus 0, that is equals to 4. Next 4 plus 1, that is equals to 5. Yes. Now out of this, what is the energy? Let us write here. the energy of 1s orbital is less than 2s orbital, 2s orbital energy less than 2p orbital, 2p orbital energy less than 3s. Okay, so from these 4 we arranged all these 4 in this order, that is least energy to gradually the energy increases. Now we have to from here we have to continue. Okay, it is 4, n plus L value is 4, and here also n plus L value is 4. Okay, and 3p orbital and 4s orbital, n plus L value is 4. For both of them, n plus L value is 4. When 2 orbitals having same n plus L values, the orbital with lesser n value, that is 3p, lesser n value is least energy. So therefore, 3p orbital is lesser energy than 4s. So it is less than 3p, then 4s, energy of 4s is lesser. Okay, after that 4s, now you have 3d orbital and 4p orbital, n plus L values are 5 and 5. Okay, that is for 3d orbital and 4p orbitals are n plus L values are equal, 5 5. Okay, now the orbital with lesser n, that is 3d, 3 is lesser n is least energy. So therefore 4s less than 3d, then 3d less than 4p. Okay, so like that we can arrange all the atomic orbitals in the increasing order of their energies based on these fundamentals. Okay, that is energies of atomic orbitals can be determined like this. Okay, I think the concept is clearly understood. The orbitals with lesser n plus L value is the least energy orbital. Okay, or you can say the orbital with higher n plus L value is higher energy. Okay, so that means n plus L value is directly proportional to energy of the orbital. Okay, suppose if the 2 orbitals have the same n plus L values, the orbital with lesser n value is the least energy orbital. Okay, clear, right? Next, electron configuration. Okay, so energies we have done. Next heading is electron configuration. Yes, what is the electron configuration of the elements? That we have to verify now. The next one is electron configuration. Electron configuration. What is that electron configuration of elements? See, for example, nitrogen atomic number 7. So we have the electron configuration. We will write normally like 1s2, 2s2, 2p3. Okay, what is mean by electron configuration? How we can define it? Electron configuration. The definition of electron configuration, right? Electron configuration. Electron configuration. What is the definition of electron configuration? The systematic distribution of electrons among the atomic orbitals. The systematic distribution of electrons among the atomic orbitals based on some arbitrary rules. Based on some arbitrary rules is called electron configuration. What is it? The systematic arrangement of electrons. The systematic arrangement of electrons among the atomic orbitals based on some arbitrary rules is called electron configuration. Okay, that is the definition of electron configuration, right? What is it once again? Arrangement of electrons, or you can say distribution of electrons. Distribution of electrons, where electrons are distributed? Electrons are distributed among the atomic orbitals. What are the atomic orbitals we have? 1s, 2s, 2p, 3s, 3p, 3d, like that. All we have atomic orbitals. Okay, so that is systematic distribution of electrons among the atomic orbitals based on some rules, definite rules. Okay, that is called arbitrary rules we are describing. Okay, the systematic arrangement of electrons among the atomic orbitals based on some arbitrary rules is called electron configuration, right? Now, electron configuration, okay. For example, nitrogen, we can distribute the electrons like 1s2, 2s2, 2p6, 2p3 like that. So we can distribute like the electrons, okay. So based on rules we have, okay, that is no problem. But sir, what is the representation of this configuration? That is called notation of electron configuration. Notation of electron configuration. Notation means method. Method of representation of electron configuration. Which method we are following to represent electron configuration? That is called NLX method. NLX method. Okay. What is the method to represent the electron configuration? That is NLX method, where N represents the principal quantum number. Okay, the orbit. Okay, N represents the orbit or principal quantum number. L represents subshell. N represents shell and L represents subshell. That is azimuthal quantum number. L represents subshell. S subshell, P subshell, D subshell. Okay, so that is represents subshell. X is representing number of electrons. For example, 2p3. That means the 3 electrons present in the second orbit. That is N is equals to 2. And the 3 electrons present in p subshell. So L value for p subshell is 1. Okay, that is NL. Okay, this representing N and this represents L. Okay, second orbit, and this is representing p subshell. Okay, NLX method. Okay, so where N is representing orbit and L is representing subshell and X represents number of electrons present in that subshell. Okay, electron configuration and notation, that is method of electron configuration is done. Once again, what is meant by electron configuration? The systematic arrangement of the electrons. Okay, the systematic arrangement of electrons based on some rules, based upon the rules. Okay, next, what is notation of electron configuration? The method of electron configuration is NLX notation, NLX method, NLX method. Okay, right. Now the next heading is, what are the rules to be followed to write the electron configuration? Rules involving to write electron configuration. Rules involving to write electron configuration. What are the rules we have? Rules to write electron configuration. Okay. Rules for electron configuration. Number 1, Aufbau principle. Aufbau principle. Aufbau principle. It explains that how the electron enters into the orbital. Which orbital the first electron goes. Aufbau principle. Next, second one is Hund's rule of maximum multiplicity. Maximum multiplicity. Maximum multiplicity. Hund's rule of maximum multiplicity. And the third one is Pauli's exclusion principle. Pauli's exclusion principle. These are the 3 important rules involved to write the electron configuration. Okay, first one is Aufbau principle, second one is Hund's rule, third one is Pauli's principle. Okay, Aufbau principle, Hund's rule, and last Pauli's principle. Okay, yes, these are the 3 rules involved in writing electron configuration of species. Okay, so the distribution of electrons among the atomic orbitals is based on these fundamental principles. Okay, we should remember them: Aufbau principle, Hund's rule, and Pauli's principle. Okay, first heading is Aufbau principle. Okay, and what is the statement of Aufbau principle? Right, so Aufbau principle states that, because it is a principle, so we cannot say that it is a definition, it is a statement. Okay, the statement of Aufbau principle. Okay, you can say like this: Aufbau principle states that electrons enters into the atomic orbit. The basic fundamental of this is how the electron enters into the atomic orbitals. Say for example, we have a group of atomic orbitals. See, we have all the atomic orbitals are there. All the atomic orbitals means what? 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, 5f, 5v, like that. So all atomic orbitals are available. Okay, and how the electron enters into the atomic orbitals, that is the main task of this principle. So according to this principle, electron first enters into the atomic orbitals having least energy. You got it? Electron first enters into the atomic orbitals having least energy. That means, or you can say like this: electron occupies, it occupies which orbital first? Electron occupies the available lowest energy atomic orbitals. Okay, electrons enters into the atomic orbital having least energy. That is one way of explanation. Next, electron occupies available least energy atomic orbital first. That means the construction of electrons, or you can say better like this: building up of electrons. Building up of electrons, that means how the electrons built up in the orbitals. Building up of electrons among the atomic orbitals. Building up of electrons among the atomic orbitals in the increasing order of their energies. In the increasing order of their energies. That means lower energy first electrons enters, then as the energies increases, the building of electrons into the atomic orbitals takes place. Once again, what is that? Building up of electrons among the atomic orbitals. Building up of electrons among the atomic orbitals are in the order of their increasing energies. Okay, that is called Aufbau principle. Electrons occupies available lowest energy atomic orbitals first. Okay, that is a statement of Aufbau principle. Okay, I think it is clearly understood. Once again, what is the statement of Aufbau principle? Reveal it. Yes, Aufbau principle states that electrons occupies available lowest energy atomic orbitals first. Okay, that is a main point of Aufbau principle. So that means first electron occupies the lowest energy atomic orbitals. Like that means lowest energy. Remember, so just earlier only today's session, so we completed the energies of atomic orbitals. First electron occupies the lowest energy atomic orbital, the next lowest, then next lowest, then next lowest. So that is the building of electrons takes place in the increasing order of their energies. Okay, right. So it is based on n plus L values only. Earlier we explained that energies of orbitals. Okay, so now we have bunch of orbitals are there. We can calculate n plus L values of all the elements, all the orbitals. Okay, so now based upon all n plus L values, the Aufbau principle, based upon n plus L values, the Aufbau principle is simplified. Based upon all the n plus L values of orbitals, Aufbau principle is simplified and diagrammatically represented. Okay, and it is diagrammatically represented. The diagrammatic representation of simplified form of the Aufbau principle is called Euler's diagram. Got it? Euler's diagram. Okay. Euler's diagram. Euler's diagram, that means Euler's diagram represents the simplified form of the Aufbau principle. That means the energies of atomic orbitals. He explained like that. Okay, now let us draw that Euler's diagram. Okay, up to 10th class you studied, that is the circles are there and electrons enters through the arrow marks. Okay, the same concept is same, but slight modification. The representation, basic fundamental cannot be changed. Okay, the slight representation is modified. Okay, let us see this, discuss this one. So this is first orbit. First orbit, one circle. Second orbit, we have two circles. Two circles. And third orbit, we have three circles. Three circles. So three circles are there. Next, fourth orbit, we have four circles. One, second circle, third circle, fourth circle. Okay, 1, 2, 3, 4 circles. Next, okay, 4 to 1 decrease now. 1. The same you studied in the 10th class. The same I am giving, but with a different representation. Okay, but the basic fundamental in both is same. Okay, that is 1, 2, 3, 4 circles. Next, 4 to 1. 3. Next, 2. And last 1. Okay, so this is let us mention with different chalk. See, this is in the first orbit. First orbit, it is second orbit, and it is third orbit, and it is fourth orbit, and it is with fifth orbit, and it is with sixth orbit, and seventh orbit, and last we have the eighth orbit. Okay, like this. Now let us this is in first orbit we have 1s subshell. The subshell in the present in the first orbit is 1s. Next, in the second orbit, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, and 4f. Next, fifth orbit, 5s, 5p, 5d, 5f, 5f, 6s, 6p, 6d, 7s, 7p, and last is 8s. Okay, these are the various subshells we have. So, according to the above principle, first electron enters into the lowest energy atomic orbital, that is 1s orbital. Okay, this s orbital is filled with maximum, so that is maximum capacity of the subshell orbitals. I'll write s orbital can accommodate maximum capacity 1 to 2 electrons, and p orbital can accommodate maximum 1 to 6 electrons capacity, and d orbitals having the capacity 1 to 10, and f orbitals can accommodate the capacity maximum, that is 1 to 14 electrons. Okay, that is a maximum capacity of the each there is various orbitals. Now, after filling of the 1s orbital, the next electrons goes into 2s orbital. After filling of 2s, the next electron enters into the 2p orbital. Then, after the 2p, the next electron goes into 3s. Then, after that, it enters into the 3p orbital. Then, 4s orbital. After filling of 4s orbital, the next electron goes into the 3d orbital. Okay, then 4p, and then 5s orbital. After filling 5s orbital with 2 electrons, then 4d orbital, it is completely filled with 10 electrons. After completely filling with maximum capacity, that is 10 electrons, The next electrons goes into p orbital. It is filled with 6 electrons, then goes into 6s orbital. After that, the next electrons enters into the 4f orbital. It is filled maximum up to 14 electrons, then 5d orbital, then 6p orbital. After that, 7s orbital. After completely filling of the 7s orbital, the next electrons enters into the 5f, then 6d, then 7p, and then 8s. So electrons progressively filled in the atomic orbitals based upon n plus L values, energies of the orbitals. So this is nothing but the maximum capacity of electrons in each subshells. Okay, that is based on this order. Based on this order, the subshells are filled up like this. Okay, based on this order, the subshells are filled up like this. So this is the maximum capacity of various subshells. Okay, so that is Aufbau principle we have done. So tomorrow we can take up in the next session, that is Hund's rule. We'll discuss tomorrow session. Okay.